during today's webinar, we will introduce it is a DFM DFA solution, which allow you to build up or upgrade your existing solution to a more high-level capability. So first, there's some advanced webinar notice for next week. So we are going to have more webinar for the industry challenge and our solutions. So next week, we will talk about some core SMT process digitalization. The time may be we're not finalized yet. Yeah. For today's session, it will last around 1 hour. So first, we will give the introduction of Vayo company and our DFA solution for PCB for the SMT industry. Then second, we will give you live demonstration of our software. Okay. Okay. So some friends has seen our solution before, but for someone first time to see Vayo, Vayo is not new to the industry. We started January of 2005. We we don't touch hardware equipment. We don't touch shop floor data collection system. We just dedicated in the new product introduction software field. Yeah. So all of the software are developed by our team. So because the co-founders are also technical guy from the SMT industry. So I'm also one of the co-founder of this company. So we realized that for software intellectual property, that's quite important. So we make a continued innovation, though we also we not only wins the copyrights for every product, we also receive the patents from different countries like US, Japan, Europe, China, Korea. Okay, so why I say this is a high level capability? Because I think you are all the expert for the SMT industry. So in the past, Vayo, the Israel company that's pioneer for the DFA solution for the electronic industry. But in the past, they're the only 2D solution, and due to the acquisition and the merge of various solutions, so the innovation process is quite slow. Yeah. So for Vayo, we start our DFM solution around 2008. Then 10 years later, we upgrade our solution from 2D solution to 3D solution. So then that's why we received the IPC Innovation Award. Yeah, so the CEO of the IPC presented the award to us, and even went to our booth and took a picture. Okay, so Vayo have more than 20 products. So here are the major products, are the typical products we are offering for our customers. So the DFM solution could be used in both manufacturing and design side. So then we also have the solution for the manufacturing production preparation. It including the smart pick and place programming solution, and also a solution for testing area, DFT testability, test strategy analysis, and the output for the test and inspection machines. So stencil solution, that's a solution we launched in recent years. We realized that so the past stencil, that's quite cheap, but very interesting. The stencil, that's a core process for the SMT production. For the core SMT production, so uh, so we launched this solution to help our customers to digitize their know-how. So because in recent years, due to the frequent MPI activity, it brings a challenge for the stencil validation, uh, requirements communication, quality insurance. Okay, so we also have a solution for VA8's instructions and board viewer. This year, we also launched a solution, CAM solution for SMT industry. And we all know that those CAM solutions existing in industry are mainly for PCB fabrication, so they add some function and they're used for the SMT factory, but it's not dedicated for the SMT factory. So we launched a solution called CAMS 365. That's a solution dedicated for the SMT factory. You will see some exciting features and optimized method for the process engineer. Okay. Since all the co-founders are the technical guy, we don't spend much emphasis at the marketing side, especially at the initial 2 years. But we still have customers from more than 20 countries and regions worldwide. So, and those customers are from different industries. So you see customer from telecom, computer, consumer electronics, automotive, energy, security, medical. For the equipment player, they also use our software internally. Definitely, the biggest ones are the EMS, the contract manufacturers. In the past, many used by the global EMS players, but now there are some no volume, quick turn players also use the software to their quick turn assembly. Okay, so here are some samples for the US. I will move very quickly. Yeah. So a couple of months ago, we received a testimonial from Amchung. That's a quick PCB assembly CM in the US. They've been used our software for 3 years and proved that that's an excellent solution for the industry. So before they introduce our software, they use mental vendor software. Now they move to our solution, and they are satisfied by the easy way of the software. Most importantly, they expect that to build a high level, advanced DFA capability comparing the other CM players. And now the feedback from their customer, that's positive. Yeah. So customer is happy to for the 3D report. Okay. So here I'm going to give you the introduction of the solution. I will bypass this industry challenge very quickly. Okay, so in general, we are just building some small PCB. It's small part, maybe in many of product, but I would like to say that's quite important because the PCB it's more like brain or heart of those products. So any malfunction of the PCB could bring a big trouble to our life, to our company business. Okay, so I think in the past we all encountered some industry challenges. Whatever you are from the product development or from the prototyping or the high volume production, or even at the post sales service side. DFM has been approved that's a high efficient way, ideal way to solve this problem and transfer the knowledge, enforce the best practice. Okay, so back to our automatic software for the DFM DFA check. So the methodology of the software that's quite simple. First, we will try to simulate assembled board. Then, based this virtualized PCBA, we will perform thousands analysis and check every details of the PCBA. Then you could review the violations, then select the critical ones to generate to final report. So with the dual monitors, you could easily use the software. It allows you to have better visibility to your products. In general, the software supports PCB CAD and BOM data sources. For the PCB data, it could be a CAD like Autumn, Designer, Cadence, and Eagle, Mentor, Expedition, ORCAD, Ruken. It also could be the third-party CAD like ODB++. We all know that the IPC is promoting a new intelligent data standard called IPC 2581. We are also helping the IPC to promote this standard in Asia. If you don't have the PCB CAD file, you could use Gerber plus Centroid XY data. So the 3D component package library, that's a key for the simulation of the PCBA. So for Vayo, we simulate not only the body, also the pin element of the component. Okay, so value checking rules coming from the IPC guideline and our industry experience. So for the design for fabrication level, we check each layers. For assembly, we check every process such as printing, pick and place, with flu, manual assembly, wave soldering, inspection, rework. Yeah. So you can see that assembly that's more complicated than the fabrication. That's why we have more than 1,000 check rules for assembly. Where you make a continual innovation, so every year we add around 50 new checking rules. So for the new challenges, we also commit customer to develop new checking rules. So if first that in this rule manager, that's quite flexible. You could either to create new checking rules, but if you find that the algorithm existing algorithm couldn't meet your expectation, you can get back to us. Our team will study and to see when we could develop a totally new checks for you. Finally, the violation, the problems shall be highlighted on the virtualized PCBA. So even on the ground, the component body. We all know that for the PCBA, we may need to reform the pin shape. So Vayo also comes with a unique feature, allow you to reform the pin shape to match the actual PCB assembly. Finally, you could select the critical problem and snap a 3D picture and generate it to final report. It not only allow you have better communication with your design, purchasing, engineering department. It also allow you to demonstrate the high-level capability of the cast. For the senior engineer, maybe it's easier to understand to the 2D report, but there are some also key decision managers of the customer. So if they could see the 3D report, they should be more easy to understand the problem. Then they could consider that you have more advanced high-level capability compared with other CM players in your area. Okay. I will not explain how easy and fast of the software. Yeah, if required, you could try the software. That's quite flexible to check the rules. So you can see this in the knife demonstration. So if you have EDA tools installed on the software, so you could have more effective ways to feedback this problem. Design change. Okay. So for Vayo, we also can export, transfer the PCBA information to the system. We support, as you can see, PTC Korea, Siemens UG, yeah, SolidWorks, really, yeah. So you will see the every pin element information in the mechanical CAD, or if you use some simulation system level DFA tools, we also could support you for that purpose. Okay, in general, the software could find out 3 to 4 levels problem, including design omission mistakes like package mismatch, missing polarity mark on the silk screen. You also could find some difficulty blocks for the quick time assembly. So if you are running a high volume production, we could find the issues related to the quality and the cost. So it will help you to improve the first pass yield, reduce the scrap rate. Yeah. None of the company would like to encounter the business problem like Samsung Note 7 mobile. So in Vayo software, we have plenty of checks for the reliability. Okay, I will not explain details of this problem. Yeah, we could spend more time on the live demonstration of the software. Okay, so design emissions, the mass production related issues. Yeah. So if required, we could share you this solution presentation, also sample report. Yeah. So whatever you from the manufacturing or the design department, these tools could be very helpful for you. Yeah. I also let you know that we are developing the more advanced DFX solution. So this is application software. We are also developing a platform system for the DFX check, which could be used for the bigger organization. Yeah. So we already released a Chinese version. So we are working on the English version. So it will be released in the coming months. Okay, now we move to the live demonstration of the software.
Okay,
Okay,
thank you very much, Howard. Okay, please allow me to share screen from my side.
Okay.
Okay. Anyone see to my screen, sir? Howard, can you see to my screen right now?
Yes.
Okay, so let's get started. Okay, this is the main interface of our DFM expert here, but before everything, I would like to revise before the DFM mechanism here. So basically, we import some data and we achieve the virtual assembly with the help of component library and a pattern technology called autoplace. Then we're going to run the core of the DFM check, which is the rule checks with the rule manager. And of course, we have to manually verify it into a 3D report. This flow may be simple, but this also contains the DFA process. For the DFF, it can be even shorter. Now, please follow my lead for a demonstration. Okay, here you can see this main interface. Some of you may already familiarize with our software. This is a menu bar, toolbars, and some windows here. So one of the things we can follow is the DFM standard flowchart. We follow this 1, 2, 3, 4, 5, 6, 7, 8, and you can finish the DFM analysis. Now I'm going to import a CAD file as the PCB data. Just like Howard said before, we support many different kinds of PCB CAD format. And if you don't have one of them, you can also import by the XY data, which is the Centroid data, of course. But we don't have to select any of these things here. Simply, we just find the file you want to load in, and the software is going to automatically understand what kind of a format that is. Okay, this is a few minutes before I start sharing. During this process, the computer may run a bit of slow, so please be patient. Okay, now we can see to the screen. One of the major functions that DFM can do that everybody always forgot is it can allow you to check on the board and see if these things are existing on the board. This is a layer manager. You can switch the layers to be on, or you can disable the layers to show. And of course, this one also contains the component package information from the CAD file. If you're loading up the Centroid data, you may not find the CAD file button here. And other things I have to do is to import an assembly BOM to enrich the process. Here I'm going to select the one, and here I'm going to use a template. And please be careful with these things here. They are the conditions to running the BOM self-checking. Allow me to click upon import, and you will see the BOM self-checking report. For example, here it shows the actual quantity of 3 for these parts. There's 3 reference, and they only have 2 on the quantity column. So this is some errors on the BOM. It will gonna inform you, and don't worry, this report is gonna save into DFM final report. Then I click upon next to initialize another function for the BOM and CAD verification report. You can check around here, these in the BOM, but not in the CAD, but not in the BOM. These are not to be assembled. But if you pay really good attention here, this could be a problem, because if you see some components in the BOM but not in the CAD, this means there's no reference on the board to assemble them. Please be very careful with them here. For the others, you may trim the zero and let the software understand them. You can end this process. Also, this validation report is going to join in the final report. Okay, now we have finished the first step, data import. We have to finish the second one called the virtual assembly. We're going to visit in the virtual warehouse 3D component library and get the components, then make the auto placement. So here I'm going to visit our component library. Our component library is saved with 200,000 of free components and other more. If you are interested on that, we can develop this point later. And once you can hear, it's quite a complicated interface, but don't worry. Just click upon one, you match the manufacturer names. Second, you match by the library. And three, you check for the replacements. Then you can leave this process. So here we're going to do it. Now we have find all of these components manufacturers, and here we're going to ask the virtual warehouse manager to get those components from the warehouse to the job. Here are the choices I have already selected, and if you want, you can uncheck or something, and then you click on OK to run it. Okay, during the running here, I would like to show you one of the things with our component library. In our library, everything of this component is saved here for the size of the pins and size of the bodies. All information came from the datasheet. This allows ourselves to add more attributes to one component module to let it be more function during the rule checks. For example, if you want to have the automation, you better set different attributes to these components and to other things as well. So these components already been assigned with the component type, pin usage, and even more to go. If you want to set other things like materials, masses, or others, you can cite in the library here. And once we have seen this finished, we can find that all 33 of them were found, and there are another 2 we cannot find in the library. One of them is a fiducial mark, and another is a test point. These 2 are non-electrical components, so you can ignore this one. And then we're going to run number 3, check for the substitutes. And here we can check on the substitute from the BOM, and according to the tolerance, it's going to give you an automatic analysis. So you have to just check whether this one could do or it's not. Okay, from here we can see the green one is the main part and the red one is the alternative. This one looks good. This one looks good also. And for these things, perhaps this is a little bit too small. You're not happy with this one, you can save it to the report. And once you have done this step, you can end this place. Okay, now before we go to the placement verification, which is the auto placement, we're going to assign some more attributes to this component. According to the package type and the component type, we're going to assign with some assemble type. Just click upon that and we can leave it. This is for the rule checks to run. And here we're going to make a automatic pattern placement verification. Just click upon verify and the software is going to automatically adjust the angles and the first pins according to the CAD file. And here you can see for this component, this is too small. This is definitely not a 1206 for these paths. So we're going to save a report into the final. Okay, now we have finished the virtual assembly. Now let's, I know some of you may not be happy with the speed, but sorry for keep you guys waiting. Here is the 3D board for your reference. Okay, so if you look closer, you can check that here we have seen the signals and the pins and something else. And this is not just a fixed, you can rotate, you can change another leading point. You can zoom in, zoom out, you can change the settings for the colors, you can change the backgrounds, the blends and everything. And also more importantly, You can just export this to the Pro-E, to UG, and to SolidWorks. If you have such software in your company, it's going to be very easy for your board virtualization. And here, I'm going to save some pictures for the final report. 3D top, and this one is a preset angles. Here we're going to say, okay, this is for bird view from the top and from the end. Here I'm going to make it into 2D. Okay, now we're going to minimize this one and put it right here just to make it work a little bit later. Now we're going to confirm the PCB flow. The wave side is going to be the bottom side, and the flow, and here we're going to set this one as 1.6 millimeters and click upon apply. Before we go to the next step, the DFM rule check, I would like to let you see one of the rule library here. Okay. And while the rule is running, we can show you the flexibility of the rule library. Okay, here, as you can see, there are many rules are running already. So let's go to the rule library. Okay, this is another library and another very complicated interface right here, but allow me to give you more guidance. The structure of the rule group is the top is a rule group and everything inside or many rule classes. Within every rule classes, many rule items. This is what we call the rule checks. And if you already copied something like for another rule group here, it's very easy to copy from the standard rule group, and you can re-edit some rules according to your regulations. For example, let's see, perhaps, okay, for this one is checking the BGA to connector TH. This is for clearance check-ins. And everything for this rule is shown up here. So allow me to tell you the structure of the rules so you may understand how flexible it is. This one is called body-to-body and algorithm. This is an algorithm. For different rules, they may have different algorithm. For this one is component summary. And for our rule here, this one is for body-to-body. And we have an algorithm. We have condition number 1 and condition number 2. The number 1 condition is for layer components and BGA, and the second condition is for connector TH. So some of you may understand already. It is to run the 2 conditions with the algorithm, and you will get a result. The result is going to show in form of a figure. And here you can see we have set for different severity intervals. For example, if the figure as a result falls into this interval here, between 0.1 to 120, it is going to show alert as severity level red. If it falls up here, it's going to show severity level orange. Okay, so some of you may ask, if I want to make more rules, can I do that? The answer is actually yes. So for example, here we can change the layer type under the component type. If I don't want to check for the BGA clearance, if I want to check for perhaps QFP clearance, I can make, so this is not QFP, sorry. Let's see, this is QFP. And we can move this BGA over there and click upon yes. And we can change the rule name itself. We can change it right here. Distance BGA, we can change this to the QFP. Okay. And also we can change the severity intervals and others. And this is just the teaser for how to edit the rules or fine-tuning the rules. We have many other rules, many other algorithms. If you know it better, you can do the edit on your own. For we already understand this core of the DFM process is the rules. different companies may have different regulations for different products. For example, some major players, they may set for different rule groups for like cell phones, for computers, for recreational electronics, for servers, for car, motorcycles, and others. And different rule groups, they may set with different intervals and enable or disable different rules. And sometimes they may change the specification and the precautions according to their choices. So we made the rule group very flexible for different customers using. If you are a CEM or EMS company, you can use the rules here. You can check on the board for a better prototyping cycle, or you can show your customer of your better enable on the DFM process and even on the quality of the product. And here is something more with the rules that you can set a new rule group and you can even add some new rules. This is for some senior engineers to do so, because having this rule here in the library is not just a tool to analyze. It's also another method for know-how digitalization. You may not able to have a senior engineer in the company 24/7 every day of the year. And once you have set his expertise into different rules according to the company regulation, even a senior engineer can run the DFM checks, and even him can finish the results and check upon them into a DFM report. This is going to give you more availability for the DFM check-in and from the engineer management process aspect. Okay, now let's go back to the DFM here, and the rule is already been finished. Okay. Well, we may have a glitch right here. Never mind, I'm going to launch another one. This is a small glitch, but how could it be? Okay. Oh, the rules are still running here. Okay, while the rules are running, we can also check on another rule here. For example, if I want to copy one rule into another new rule group, I can make a, for example, for, let's see. Okay, for this one here, it checks for the distance between a SMD pad to a pin through hole pad. For this rule, some of you may understand the distance between SMD part to the through-hole components. They can be verified to different angles, but one of a major concern is that PTH, this one may go through extensive heat and temperature influence for that. And that is going to affect on the deformation of the PCB board itself, make it expand up like a bread in the oven. And finally, it's going to influence on the PCB components, such as the CC, CRs in the ambient area. So this rule, you can check it and make it a better view for your team to understand. So here I'm going to create a new rule class here. So ASS, and we say for PTH clearance. We're going to set for the bottom and the inner types, and for the unit we can set to MMs. Remarks, you can set them according to your choices. And here I'm going to put the rule here. And right here I may change many things for specifications. For example, this is what we call PTH too close to SMD components. Symbol. And also you can check for here and change some side. This is for wave side and this is for pads, because this is something we have already know. And the second condition here is to use this component feature as non-SMD usage for pins. And this, when we understand this is a TH pin, this is going to be available between the interval for 0 to 160, and this is one is in millimeters. So I'm going to have to let it down to perhaps say 4 millimeters. It's going to be enough. And then we can run this rule to the PCB and if we check. And also, some of the engineers, they may have this kind of a situation before, then they're smart enough to avoid this this interfere from the PTH to the SMD components. They're going to add one small via here, and that via is going to be used as a reference to fix the PCB board from deformation. Okay, here the rules are finished. Let's go to the final step to check it into the manual DFM report. Before we run the checks here, before we review the checks here, I would like to launch the 3D board Vayo also. And we do recommend you to have a dual screen system for this application. For sometime you may view the 3D and have the 2D on the other side. So let's see. Okay, now let's try to see something on the board. And here we have a CC2 connector TH. As some of you may already understand, the CCs are very sensitive to the strengths and to the G-force and even sometimes for the temperature. So from the 3D board view, we can see it very easy that the distance is too close. And once we have find a good angle, you may save a 3D board view report from different angles preset, or you can check it manually according to your better judgment. Okay, so we have a small box right here. This is for pictures. Take the 3D pictures. Okay, now perhaps we can check on other rules. Perhaps let's see. For the SOP and connectors, these are really close as well. This one is going to create more issues during the rework in the future. So this was a real talk guy here. I'm going to save this 3D report. Okay, so this is for DFA analysis, and perhaps you can check for others, like for the fabrication. Here we can check on the check trace angles. And for the ring width of a PCB, here we can magnify this one here. And this one you can see, this is not a really big annual ring and not a really good annual ring here. So for the fabrications, you can save on 2D report or even on the 3D board view. There are many others for check diameters of a via holes. We have a recommendations here. You can check your own via hole diameters here, just in case that you receive the design from another company. For the EMS is basically it's going to be useful. And there are basically more other rules, but we don't really have enough time for today to check every rule here. So I would recommend you to view some of our demo parts, demo reports. Okay, this report template, we can even change it to your company regulations if you require certain service. And here is the template as default. You can save the report in Word or even Excel or even HTML according to your company regulation. Okay, for some of you may understand the DFM process is basically you search and try to expose as many issues as possible before the board goes to the fabrications. So in this stage, the DFM engineer must understand many of these features upon to, like, say, designing for like SMD department, for the reflow department and others. He have to understand something, and after he find some of the issues, The next is to negotiate between different departments. And with this the 3D report, you can see this issue is shown here very intuitively, and people will get it very easy understanding. And we also have the coordinates and everything else on the board, very easy to find it. And if you are management in your company, you can share the DFM report from different locations to another. If your company have the SMD component, the SMD department in another country and design on another one. This is really common for these recent days. And if you really like this one to see as a sample, we're going to send over this 3D demo for the report and later after this session. And here, I'm going to look down to the end of the report. This one is for checking for the fabricators. Some of the fabrication issues, they may find the fabricator is going to contact you with ECN and says this is beyond our manufacturabilities and you have to change the design. To deduct the MPI cycle, you may just consider to end this issue from the design at the beginning. Okay, this is the appendix for the part information summary and for the BOM verification report and the BOM and CAD verification report. Just select set before, and here we also have a no part library list for you to create into the component. Okay, Howard, do you have any other things that for review? Perhaps I missed something.
Have you showed the checking rules we developed last year?
Oh, sorry. Okay, so before that, we show you that the structure of a rule is basically with one algorithm, and you set two conditions, and this gives you more availability to create different rules. Let's say if we have this one algorithm and different conditions, you can set as many rules as possible as you want. However, you do need the algorithm. So when you upgrade many algorithm every year, this is something we have update every year. This is for year 2020, and here are the rules. And more importantly, we have upgraded many of the algorithm. Here is the algorithm for checking on the multiple parts on the shared path. And sometimes we can check with this algorithm part aspect ratio. Not recommended to use this device for is an aspect ratio for the device selections. Such device has poor installation stabilities. And also for thermal conduct areas, for the concave, part coordinates and left down coordinates and others. This is footprints to footprints checking. So with this new algorithm, it gives you some more availabilities to set new rules, or even just contact us if you are not really familiarized with the rule group. We can do the rule editing and we can do the rule configurations for you. Okay, does Howard, do you have any other things to remind or?
Okay, let me be the present. Okay, let me share my screen.
For you.
If we want to move deep to our solution, so we can offer try license with full functionality. Yeah, so just send an email to builders@vayoinfo.com or take_expert@vayoinfo.com. We will send you the trial license request form. So once you submit the form, also generate a XML file for your trial computer. We will generate the license. Also send you the installation download link. So once you accomplish setup, you could follow our video or manual to try the main function of the software. Yeah. So if you have any question, so you can raise your hand, or you can also text a message. Yeah.
Okay, thanks everyone, and hopefully we can contact soon and to get to your need, and perhaps we can give you more better guidance upon the DFM solution. And also, if you have more thoughts, more concerns, or more ideas upon the DFM solution, or to the rules, to the other things you want to chat with, we're always free to talk with you. Just 1 mile, and we're gonna come back and link to you back as soon as possible.